Okay guys, welcome back to another video. Today we are going to prove Theorem 2.4.4, which states that let a and b be integers such that a is not 0 or b is not 0 and m is a positive integer. Then the greatest common divisor of MA and MB is M times the greatest common divisor of A and B. If you have these two numbers of greatest common divisor with common factor, let's say M, you can write M in the front of greatest common divisor of the two number. Okay, so let's try to prove this. But before I prove this, I have to give you this theorem first, which are theorem we proved in previous video. And this theorem for division. The first one is that if you have d divide a and d divide b, then for any integer x and y, you will have d divide ax plus by. This is the property of divisibility. Okay, and the previous theorem, which is if you have the greatest common divisor of a and b, you can find two integers x and y such that the greatest common divisor of a and b equal to ax plus by. So we will use these two theorems to prove this. Now let's start to prove. So we let a and b be integer such that a is not 0 or b is not 0, and we let m to be a positive integer. Then you want to start with the greatest common divisor of MA and MB. So we gotta let D to be MA, MB like this. So let D be the greatest common divisor of MA and MB. And I gotta let small d to be the greatest common divisor of A and B. Okay? And what do we have to show? We gotta show that D equal to MD. That's what we have to show. So we want to start with this term right here, the greatest common divisor of MA and MB. So let's start with this greatest common divisor. So we have to use theorem 2.4.1, which is this one right here. Now if you have the greatest common divisor of MA and MB, we can find integers, let's say x and y. So I gotta use x, y, u, v as integers because we want to use theorem 2.4.1 with this greatest common divisor and the small d, which is the greatest common divisor of a and b. Okay, so we gotta have d equal max plus mby. And what is our d? D, which is the greatest common divisor of a and b, is going to be a u plus b v. All right, and then we have to start with this term right here, the greatest common divisor of MA and MB. Okay, so we start with D equal to MA MB. All right, so what do we have? So we're gonna have D divide MA and D divide MB. Then what do we have here? So I want to rewrite I gotta try to write this D that divide MD. Okay, so I start with this greatest common divisor first, and then we have to use this one because D divide MA and D divide MB. So by theorem, I don't know how to call it. I gotta call it star. Okay, by theorem star. So what do we have here? We gotta have D divide D divide MA times S plus MB times T. Okay, for all or for every integers S and T. Okay, for integers S and T. Then what do we have next? The next thing that we have to do is to, so we have S and T be every integer. That means that we can plug in any integer into S and T. What we have right here is we have U, because I try to write this term in terms of D, small d. Okay, in terms of small d. So I gotta plug in U and Z. So since U and Z are integers, I can plug in U and Z into this division. So what do we have right here? So we gotta have D divide MAU plus MB. Actually is V, not Z, okay? Is V. Alright? That's what we have here, okay? So D divide MAU plus MBV. And what happened to MD? Okay? So what we have next is that MD equal M, and our D is here, right? M times D. D is AU plus BV. Okay? Distribute this M, so we're gonna have M AU plus M BV. Okay? And then what can we do next? Then I gotta use associativity. So we gotta have MAU plus MBV. Okay? So what does it mean by this? That means that your MD is this term, right? This one. Actually, this guy right here is MD. Okay? So that means that we have big D divide MD. Okay. So this means that the next thing that I have to show is to show that MD divide D. Okay? Because we know that if you have D divide A and A divide D, okay, this implies that A equal to D. So the next thing I want to show is to show that MD divide big D. So I want to start with this D, which is the greatest common divisor of A and B. Okay, so our small d equal to the greatest common divisor of A and B. What do we have right here? We gotta have D divide A and D divide B. Then what do we have here? What do we have here is that you can have D divide MA and D divide MB. Okay, so that's what we have right here, right? And then I'm terribly sorry here, I forget to multiply m both sides. Okay, so apology here. If you have d divide a, then you can multiply by c both sides of this division bar. So we're gonna have cd divide ca. Okay, so from this right here, you can multiply m both sides. So we're gonna have md divide ma and md divide mb. Okay, so we need to have this theorem here and this small theorem here. Actually, we only use 4 theorem right now. So now let's continue. If you have md divide ma and md divide mb, so what do we have next? So I'm gonna use this theorem star here. So by theorem star, what do we have here by this theorem star? So we're gonna have md divide ma times x1 plus mb times x2. Okay, for every integers x1, x2. All right, and then what do we have next? This means that I can plug in x and y into x1 and x2. Okay, so since x and y are integers, so what do we have? We're gonna have md divide max plus mby. So that's what we have right here. And what is this one here? It's just d, right? Okay, as we can see, our max plus mby, mb times y is just d. That means that md divide big D. Okay, so we have shown that md divide d. Okay, md divide d, and since big D divide md and md divide big D, so what do we have? We use this one here. Okay, so we're gonna have d, so we're gonna have big D equal md, and therefore we're gonna have the greatest common divisor of ma and mb is going to be m times the greatest common divisor of a and b. Okay, and that's it for this video. So we have proved that the greatest common divisor of ma and mb equal to m times the greatest common divisor ab.